702 and Cape Talk.
The Naked Scientist.
With Dr. Chris Smith. Chris, a very good morning, a happy new year, and welcome back to the show.
Morning, Africa. Happy New Year to you too.
Does it matter, New Year, the stroke of midnight on the 1st of January of any given year in the bigger scheme of things, or do we just make a fuss about nothing really?
Well, it's all arbitrary, really, isn't it? I mean, it's a good question. Why do we attach so much significance to the 1st of January? The 1st of January is only an important date because we decided that was an important date. It could be any day of the year that we decide to start the year. And indeed, some cultures, some people, some previous races way back in history did have a different calendar. We use the calendar that was largely foisted upon us by Julius Caesar, the Julian calendar. And we've made a few tweaks and adaptations since and added leap years and things. That's pretty much what we do because that's what they did, and we just inherited it and decided not to change it.
And of course, we spent incredible amounts of time and money sometimes making the stroke of midnight perfect. You know, you're at the right party with the right people, hopefully next to your partner, and you're able to kiss them for the start of the new year. For some of us, I was sleeping and dreaming away while Cape Town was having a wonderful time. Well, Dr. Chris Smith is here for half an hour to answer all of your science-related questions. And Chris, your first call is from Bohosi, who's called in from Calvin. Hello, Bohosi.
Gentlemen, good morning and compliments to both of you.
Thank you.
My question is based on this phenomenon of time. On Earth, we measure our time by the number of times the Earth rotates on its axis, and again, the number of times that it revolves around the sun. For instance, the Earth revolves around the sun in 365 days, and we call that a year. It has revolved with me, for instance, 75 times. So that is why I say I am 75 years old. Now, my question is, if I'm in a spaceship traveling intergalactical at velocities nearing that of speed, how do you measure time, and will I actually age in those circumstances?
You've been watching far too many movies, Bohosi, but I think it's a very intriguing question. Thank you very much for asking it. Chris?
Hello, Bohosi, and congratulations on reaching the ripe old age you have. Now, the answer to your question is that we didn't know the answer to this until Einstein thought about it, and then subsequently we have been able to prove him correct. And this is something called special relativity. And relativity means that, or the premise of relativity is that the speed limit of the universe is the speed of light. Basically, nothing can break that speed limit. But if you approach that speed limit, then because everybody measures the speed of light as travelling at the speed of light, and it doesn't matter whether they're moving or not when they make that measurement, the speed of light is a constant, then time itself has to warp in order to keep the speed of light the same. So if you were to go in your spacecraft and you travel incredibly fast, time will continue to tick for you as it always has. If you had a clock that was a very accurate clock and it's ticking down the seconds, you would not see time changing for you. But someone measuring you would, because you're travelling incredibly fast, and they would see the light coming from you at the speed of light. So to keep time, or to keep the speed of light the same, the time that you were travelling for you would be a lot less than the time it's travelling for them. So if you went off from your spacecraft, whizzed around the solar system at the speed of light for a year or two, when you came back, everyone on Earth would have experienced a lot more time than you would have done. You can also warp time gravitationally, which is why I was saying about general relativity earlier. And so if you're near to a centre of mass, this warps space-time more than if you're further away. And as a result, time changes there as well. So the bottom line is that, yes, you would not see any difference in what you call 75 years, but the people who had been waiting for you to come back would have aged more the faster you travel.
A very interesting question, Bohosi. Thank you very much for asking it. Malcolm is in Irene in Pretoria. Hello, Malcolm.
Hi, Happy New Year.
Thank you. Same to you. What's your question for Chris?
Thanks. Okay, Chris, Just regarding weather forecasting, I think it's metrology. I think that's the right terminology. Would it be easy enough for a metrologist here in South Africa with, say, 20 years experience and accustomed to forecasting our weather here to, say, move to England, and easily become a weather forecaster there, or would he have to build up some experience there first?
It's really easy to forecast the weather in the UK. It's rubbish the whole time, pretty much, apart from the odd nice day. Although I would be proved wrong in the last summer, because that just was very hot, more than 30 degrees day after day after day. So that bucked the trend. But they do say climate is changing. The answer is that the principles that meteorologists use to forecast the weather are the same. It's all about physics, and it's all about how masses of air and thermals move around. Those principles apply wherever you are. What informs how good those people are is the information they have to work with. And most of that information is gathered by devices like satellites and temperature measuring devices, and it's integrated, put together into a model of what is going to happen using an enormously powerful computer system. So the more information you have to use and the more powerful your computer system, the better are going to be your predictions. Now, in some parts of the world, the data gathering is incredibly good. So we're down at, for parts of Europe, down at a resolution of prediction, say under a kilometre, 1 square kilometre. You can literally say that patch of the country, the following is probably going to happen today based on the information that we have. In other parts of the world, the data is far more sparse, and in other parts of the world there is no information over some of the oceans and where people aren't. We just don't have satellites covering those areas, so we're not watching the area changing very much there, so we have no information on which to base a model for that part of the world's surface. And you probably guessed it, we have investment in where the people are. So the satellites and other measurement devices are gathering data where most of the people are, and where most of the people are who can afford to pay for that service. So there are parts of the world where there are lots of people, but there isn't a very good coverage because it's expensive to do this, and therefore there's not much data being collected. But that will change in the future. But on the whole, your South African meteorologist could apply for a job at the Weather Centre with the UK Met Office, and their skills would be A, very useful, and B, they would probably have no problem, apart from some little bit of experience of obviously how fickle the weather can be in Europe, but they would have no problem making weather predictions based on the information made available to them there.
Malcolm, good question. Thank you very much. Johan is in Harteposter Dam. Hello, Johan.
Good morning to both of you.
Good morning.
I wear my cricket whites and go for a short walk following a bunch of zebra. And within 5 meters, I've got brown marks all over my clothing. Why is it that animals with white never seem to get dirty?
That's a good one, actually. Chris?
Yeah, well, I think there are a couple of things going on here. I'm going to speculate because I don't know for sure, but part of it is that the zebra, if you get really close to the zebra, the white is, which you can't do, of course, because they're so fickle, they just run off, don't they? But the white is going to look dirty the closer up you are, but the contrast of the white with the black means the white still looks very, very white up against the very, very dark patches. So that's part of it. I think it's a contrast thing. When you're looking at a pure white surface, it's easy to spot the dirt. Whereas when you're looking at something white with some black stripes on it, or should that be black with white stripes on it, then the white is a strong contrast with the black, even if it is dirty. The second thing is that these white stripes are made by lots of hairs, and those individual hairs are covered in various things that give the zebra its performance, as in the reason it's got those colourings, we think, and this is, we think this is the case, the reason that a group of zebra are called a dazzle of zebra is because that dazzle pattern is thought to make it much more difficult for, based on the visual systems that predators have, for them to be seen in the bush. And so they have evolved ways of making sure that they preserve their dazzle pattern. So if the zebra got too dirty too quickly and couldn't shake off the dirt, then its dazzle pattern would be less effective to it. So I think probably there are also mechanisms that make sure that the white hair, the keratin, which is the protein in hair, sheds the dirt and keeps the zebra as clean as possible. Probably because the dirt finds it hard to stick uniformly across the zebra's hairs. It just falls off, and for that reason the zebra stays fairly clean, and that keeps its dazzle pattern active, and that hopefully means it can get away from the predators.
Johan, thank you for your question. Basanu is in Krugersdorp. Good morning.
Good morning.
Good morning, Basano.
Hello. How are you?
Very well, thank you very much. How are you?
I'm good. I just want to ask from Dr. Chris that how is it possible or how does it happen when you twist a toothpaste tube, its colors, when you squeeze it out, they remain intact and they don't mix up. I just want to know how does that happen.
Basano, thank you very much for that. So why is it when I brush my teeth, the blue is blue, the white is white, and the green is green?
Have you ever chopped into a toothpaste tube? Because those people who are intrigued by this question, including me, have in the past wondered this and thought, right, I'm going to find out. So you actually, unfortunately, you have to surrender a new toothpaste tube to do the experiment. But if you chop into one, you'll see that actually in the toothpaste tube, you don't have a compartment with a uniform stripe like a stick of rock all the way down the tube, and you then squeeze it and it perfectly dispenses this stripe out of the small nozzle. Actually, there are different compartments inside the tube of toothpaste, and there's a solid sort of, if we imagine it's white toothpaste, you have a core of white, and then closer to the end of the toothpaste tube there are side channels which add on to the stuff being squeezed out some of the colour around the edges. And if you're feeling really nefarious, what you can do is with a slightly emptied tube of toothpaste with the cap on, if you squeeze it all round, especially the edges up near the neck, and you squeeze it nice and flat and redistribute the toothpaste round, you can empty those compartments at the sides, at the top, into the main compartment and mix it all up, and you end up with this stuff that doesn't look very appealing to brush your teeth with. It looks a sort of mauve colour, especially if you've been using toothpaste that have a red and a blue and a white stripe. You end up with all three blended together to make a sort of purple mush. Doesn't look quite so nice, but it does prove the point. So number one thing, if you're willing to surrender a tube of toothpaste, cut into it and you'll see what I mean. There are side compartments that add the colour. Number two, if you're feeling less daring, but you don't believe me, mush the toothpaste up and you'll see that the stripes all merge into one. And number three, wait till you've finished the toothpaste tube and then cut into it, and you'll see the now empty compartments inside that would have contained the colour.
I had no clue. Basano, thank you for asking the question. Minnie is in Alberton. Hello, Minnie.
Hello there. Happy New Year to both of you.
Thank you, Minnie. Same to you.
My question is, if I'm on one side of a palisade fencing and a car comes from my left to my right, for instance, the wheel turns, but it looks as if it's turning backwards.
I know what you mean. So, what do you call that thing in the middle of the wheel?
The hub.
The rim, basically, the mag wheel rim, whatever it's called. That looks like it's turning backwards as opposed to forwards.
Backwards, yes. What causes that?
Are you referring to this being during the daytime or at night time?
No, during the day.
Okay.
As I'm sitting on one side of the palisade fencing, the car's passing from my left to my right, but as it goes past, it looks as if the wheel is turning backwards instead of going forward.
Righto. Well, I have seen something similar when cars drive at night time on a road illuminated by street lighting, and under those circumstances, what's going on is that because the streetlights are powered by mains electricity, this is alternating current at usually around about 50 hertz. That means the light is going on and off 50 times per second. That means the wheel is being illuminated by light 50 times a second. And the reason you can, under those circumstances, see the wheel appearing to go backwards is because of a stroboscopic effect, where the light turns on and you see the wheel in, let's call it position 1. The light goes off, the wheel moves round a bit, light comes on again, and you see the wheel in now position, let's call it 2. Now, at certain speeds, as the car's accelerating, the wheel will go from position 1 right the way round, almost back to position 1, and then be illuminated again. So it looks like it's gone not from position 1 to position 2, but to position 1 backwards. Then the car accelerates a bit more, which means it might have gone right the way round now, past position 1, and almost back again on itself, and the result is that the wheel appears to be turning backwards, not forwards. Now, I don't know what's going on with your palisade fence, but it might be that you're getting glimpses in the same way of the wheel, and it's causing a stroboscopic effect, just like the streetlights I'm referring to. And that means that instead of seeing the wheel going round continuously and smoothly, your brain is presented with a series of snapshots of the wheel, and it's made to look like, instead of the wheel completing a smooth, continuous motion, is actually the glimpses you're getting make it look like it's not quite going all the way around. Instead, it's going backwards. And that may be the same as my streetlight example. So I think that's probably what's going on. It's a stroboscopic effect.
Minnie, thank you for your call. Johannes is in Pretoria. Good morning.
Good morning. My question is, when you look at the flight speed at the maximum altitude and when you look at the clouds, it looks like it's moving very slow, like maybe 10 kilometers per hour. But when you look at the average speed of the flight, is about 800 or more. So I would like to know what is the logic of that.
It's a good question, actually. So when you're inside the plane, you know that the plane is going at between, 800 and 950 kilometers an hour, depending on the power of that engine. But it actually feels like it's going very slowly than that. Chris?
I thought you were going to say, why does it look like the clouds are going really slowly from the ground surface? But that's because the clouds are a very long way from you. And if you look at the clouds relative to an aircraft, it depends on the altitude of the clouds, because the further away the clouds are, then the greater the distance they're covering across the sky, and therefore the longer they take to do it. So the longer it looks to you like they're taking to do it, and therefore it looks like it's a slower motion. The aircraft may be flying at a much lower altitude. When you're in the aircraft, you're moving, but so are the clouds moving. And therefore, your perceived velocity, your perceived distance over the clouds is the difference between the speed they're moving at and the speed you're moving at. Now, the jet stream, which is the high altitude area where some clouds sit and where your airplane is going to be flying, and say a number of kilometres up, that air is moving along at maybe 500 kilometres an hour. So some of the clouds may be being whooshed along very, very quickly up there. So actually it doesn't look to you like they're moving very quickly because you're moving with them. If you flew in the opposite direction, then they would certainly maybe look a bit faster. But aircraft try not to fly into the headwind too much because that would increase their fuel burn a lot. So that may be part of the reason for your observation.
All right. Mantwa is in Pretoria. Hello, Mantwa.
Hi. Hello, Africa. Good day to the Naked Scientist. My question is relating to my ears. I've noticed that their ears don't voluntarily move themselves, but there are people whom, when you speak to them, you can see the ears moving back and forth. And I've noticed that with me, it happens if I'm listening to a sound and a peculiar sound comes into effect, then my ear would kind of tend to that new sound and they move backwards. So I want to know what causes that.
Oh, wow. Like dogs' ears, because dogs do that, don't they? When they hear a different sound, they either prick up or they sort of go in the direction of where the sound is coming from. Mantwa, have you always had this, or is it something that you realized more recently?
Only recently.
Only recently. All right. Chris, do you know why Mantwa is going through that?
I hope you're not calling Mantwa a dog.
Not at all. Not at all. I'm appreciating the incredible skill that dogs have in being able to pick up sound, actually, and seek them out, and using their ears, I would imagine, to be able to do that, obviously. So I'm celebrating her ability to hear and to listen more so than calling her a dog. Please, Mantwa, I'm not. Apologies.
No, I liked the analogy very much indeed, as in the dogs moving their ears. And the reason dogs do this, they change the shape of their ears, is because a lot of the ability of the ears to resolve the origin of a sound is that the outside visible bit of your ears, the pinna, is very carefully crafted and shaped in order to have an amplifying effect on the frequencies of the sound that come in and create sound that is better amplified in one direction than another. That's why we have funny shaped ear holes, because that way we find it easier to resolve where the sound is coming from, and then nerve mechanisms inside the brain then further work on that and adjust the way in which we look and the direction we turn our head and even the tilt of our head in order to help us to hear sounds better. And this is why if you raise the point of a dog, it's a very good example. If you watch a dog, when you play certain sounds to a dog or make certain sounds, the dog will look at you quizzically, but it may also turn its head to one side or twist its head backwards and forwards. And it's trying to resolve where the sound is coming from, what's making it, and why it sounds the way it does. And it's adjusting its head position in order to best do that. So in other words, it's using the shape of its ears in order to amplify certain frequencies that it wants to tune in on best. We're doing the same thing. Now, we can't voluntarily easily move our ears. They're made of a cartilaginous material, the pinny of the ears. And it's not. There's no muscles in your ears to enable you to move them, but there are muscles on the face around the ears, in front of the ears, the muscles of facial expression across your forehead and so on. So you can cause gross changes to the shape of your face. Everyone knows that, to make your face change shape, and that will in turn slightly alter the attitude of the ear pinny. But as humans, we do most of that sound focusing by literally moving our heads and shifting our direction of gaze, because when we look at something, we also help the brain to pick out what it is that we want it to pay attention to, because there are connections between the visual system and the auditory system that does the decoding of sound. A very interesting story, actually. I talked to a lady a couple of years ago who works in Denmark who looks at marine mammals. Whales, for example, they do most of their seeing underwater by using sound waves. They have sonar and they emit sound waves and they send out this barrage of sound waves, and then they listen to the reflections coming back off of objects in the water to work out where there are things that, for instance, they might want to avoid, things they might want to find, things they might want to eat. The question is, though, if they're not careful, when they're first looking for something, they're going to spread the sound over a very wide area of water. But as they get close to the thing they're going for, if the sound was spread out over a very wide area of water, they would have real trouble working out where the sound was coming back from. So as they get close to the thing that they want to find, they narrow down the zone over which they project the sound. They do it with that bulge on the front of their head called the melon. And what this person found out is that in these animals, the way they do this is they use the muscles that we use to change the shape of our face and smile and grimace and roll our eyes. They use all those muscles up on their foreheads to reshape that blob of fat, the melon, so that they can use it to focus the sounds that they produce. So some animals do effectively change the shapes of their faces and heads to hear better. And dogs are one. These marine mammals are another.
Manto, that was a very fascinating question. Thank you very much. And thank you, Chris. You'll be back with your CBS next week, Friday. And for more about The Naked Scientists, you can visit their website at thenakedscientists.com. Thank you very much for all of your most interesting questions.